Today we're going to talk about perpendicular lines, and it should involve a lot of different ideas coming together, all revolving around perpendicular lines. Remember, perpendicular lines are lines that cross to make what kind of angles? Right angles that measure 90 degrees. So perpendicular lines are going to cross to make 90-degree angles, and so you're going to see a lot of 90s written on these problems today because it involves those lines that cross to make right angles. And a lot of these different theorems that you're going to see here are ones that we've actually seen before. For example, all the way back when we first started talking about proofs, I put this on a worksheet and had you prove it. If two lines intersect to form a linear pair of congruent angles, then the lines are perpendicular. Here's how this argument's going to go. It's going to combine our definitions of linear pair and our definition of congruent. What does a linear pair mean? Well, a linear pair means that they form a straight line, which measures 180 degrees. So if this line measures 180 degrees and the angles are congruent, so they have to be the same. If I have 180 degrees and the two pieces are the same, then that leaves them to be 90 apiece. So that was the proof we wrote. You don't need to write that part down. But that's hopefully something you would be able to figure out already. Since they make those right angles, that's our definition of what perpendicular is. Here it is again as a two-column proof. If the angles are congruent, that means we also know that they add to 180 because they're a linear pair. Well, if we know that, then if they're the same, that means I can double one of the angles to get 180. Solve, we get the angle to be 90, which means the other angle is 90, which means they're perpendicular. Same argument, just laid out in a different way. Next one, this should also look familiar. If two sides of two adjacent angles are perpendicular, that means they make, again, perpendicular means they make what kind of angles? Right angles that measure 90 degrees. And guess what complementary means? Complementary means two angles that make 90 degrees. So it's those two definitions kind of coming together to make this idea. The angles are perpendicular, then when I put the two angles that it's made up of together, I should get 90. So again, that has a proof. I'm not going to go through it in detail. Here's the one I am going to go through in detail. This is the one that might be relatively new to you. In a plane, if two lines are perpendicular to the same line, then they are parallel to each other. If two lines are perpendicular to the same line, then they're parallel to each other. So if I'm not told anything about M and N, I can still conclude that they're parallel because they're both perpendicular to line P. So I'm going to explain this two different times. I'm going to explain this once with geometry, and I'm going to explain it once with algebra. So here's the geometry explanation. I know that the lines are perpendicular, so I'm going to say what that means. Perpendicular lines mean they make right angles. Right angles that both measure 90 degrees. Oh, if they both measure 90 degrees, that means they're congruent. So I have these two angles being congruent. Now I look in the diagram. Top right with top right, those are what kind of angles? In the matching spots, those are corresponding angles, and corresponding angles should be congruent. And so since those two angles are congruent, that means lines are parallel. So I started with two pairs of perpendicular lines, and I led to the conclusion that the lines were parallel. That's the geometry way to show it. Now I'm going to show the algebra way to show it. and then I'll get to your question. So let's say I know, again, the lines are perpendicular. I know the slope of my line is negative 2/3. Pulling that slope out of a hat there. Just saying, let's say we know the slope of this line is negative 2/3. I also know that line M is perpendicular to it. I'm going to give you 10 seconds. I want you to write down what the slope should be of line M. If it's perpendicular to that line, what would the slope of the perpendicular line be? Let's check your work. Perpendicular lines should have opposite reciprocal. Change your sign, flip your fraction. So instead of negative, now it is positive. Instead of 2/3, now it's flipped. 3/2. And since we know that N and P are also perpendicular, the same thing is going to happen. Sign's going to get changed, fraction's going to get flipped, and we're going to get 3/2 again. And now those slopes are matching, they're the same. And I know that if my slopes are the same, then my lines are parallel. And I have arrived at the conclusion that the lines are parallel. So that's really a kind of reduced form of the exact same idea, just expressed in my algebra way and my geometry way. And that's kind of the two main ideas, actually, of this chapter. This idea of talking about the slopes of parallel and perpendicular lines, and the idea of the different kinds of angles that parallel lines make. The corresponding alternate interior, alternate exterior, consecutive interior. Those are really the two main ideas of this chapter, combined together with my perpendicular lines. But this is the tricky part. Determine which lines, if any, must be perpendicular. Explain your reasoning. So first off, we have a pair of lines that are already perpendicular. We have a pair of lines that are already perpendicular because I already have them marked as being right angles. So I can go ahead and say that those lines are perpendicular. B and C, they're already perpendicular. So we're already good to go there. However, there's another pair of perpendicular lines that we can get. There's another pair of perpendicular lines that we can get here. So I'm going to outline what the argument is, follow along with it, and then we're going to actually write it down in complete sentences. So here's your outline. So we have that right angle, but we also have these two other angles in my diagram. And they're both 75, so they're both congruent. And if I take a look, here's that angle and that angle. Oh, we know what kind of angles those are. Those are corresponding angles. And it just so happens that they're both 75, so the corresponding angles are congruent. Are corresponding angles supposed to be congruent? Yes, they are, which means that I can say that my lines are parallel because my corresponding angles are congruent. So A and B are parallel. Well, now that I know that A and B are parallel, I'm going to jump over here because I have another transversal cutting through those parallel lines, and take a look at what that creates. That creates more corresponding angles. more corresponding angles because I have top right matching with top right here. And now that I know the lines are parallel, I'm guaranteed that those angles are congruent because they're corresponding angles. And voila, I have created a new right angle. Since I have created that new right angle, that will lead me to the conclusion that those lines have to be perpendicular. The lines that I made that were perpendicular were here and here, so that is A and C. So that's the outline of that argument. Here it is all written out. Corresponding angles converse. You're using converse, like we talked about yesterday. I'm using converse in this first sentence because I am proving the lines parallel. I'm using the angles to make the lines parallel. That's when I want to use the converse. And then over here, now that I know they're parallel, I'm using the postulate. Converse when you want to prove them parallel, the postulate when you want to, when you know they're parallel already and are using that to get more angles. Small difference. So since A is parallel to B, corresponding angles, A and C must intersect to make 90-degree angles as well, because the corresponding angles have to be congruent. So that's my more corresponding angles, which gives me the 90-degree angles I'm looking for A and C to be perpendicular. Hearing no objections, I'm going on. Find the measure of angle 1. So these are all going to go quick. Here we go. This one. Well, those two angles make this angle, which is 90 degrees. So if those two angles make 90 degrees, that's called complementary, by the way. If those two angles make 90 degrees, I need to take 90 and take away the 75 that I already have to get the angle that remains, which is 15. Done. Moving on, next one. All right, next one requires a little bit more explanation because I need to justify to myself that this angle is indeed going to be a right angle. I know that that angle is a right angle because compared to this angle, which I already know is a right angle, they are what kind of angles? They're vertical angles. So since they are vertical angles, I know that they have to be the same. So if one is 90, then the other is 90. So there I have that being 90. I can take away the 30, and I'm left with 60. Done. And finally, one more. I need to get this angle being a right angle. Now this one's a little bit different, not vertical angles this time. These two angles are what? It's a linear pair. And a linear pair should add to 180. So if that's 90, the other one has to be 90 as well, so that when I put them together, they make 180. And now I can determine that this angle here, since that was 60, this is going to be 30. So to get the measure of angle 1, how's this angle going to help me get this angle? What kind of angles? Vertical angles again. Which means that they need to be the same. So this angle is also 30. Questions there? All right, we're going to jump down and do one more here together. and then I'll let you try one. That is this one. The key to this one, again, this should be nothing new. The key to this one is that these lines are perpendicular. Since I know those lines are perpendicular, what kind of angles do they make? Right angles, which means it measures 90. So I can make a right angle there. And I can say that when I put the 25 together with the other angle, the x plus 25, and I add them together, they should in total make 90. So we're going to combine our like terms. 25 here and 25 here is 50. And then we're going to get rid of adding by the subtracting to 50. So we get x to be 40. Now back here, I have one more that I skipped over. I said we'd see a lot of 90s. There it is again. Back here, I had one more that I skipped over. So this is one that I want you to try on your own here. So getting all these measurements,